Hi, and welcome back. After looking at composting and anaerobic digestion, the most common approaches for organic waste treatment, in this module, I'll try to give you a brief overview on vermicomposting or worm composting. This is one other biowaste treatment approach. Vermicomposting is using worms and microorganisms to process biowaste in a controlled manner and to produce valuable soil amendment called vermicompost or worm compost. Actually, if the main focus is to grow and market worms, then we call the process vermiculture rather than vermicomposting. But really, it's the same principle. The process of using worms is quite straightforward. We feed biowaste to earthworms. Some earthworms are more suitable than others, and we will look at that in just a minute. The worms eat the biowaste, they grow and they reproduce. We should look at what they eat and what not. As the biowaste passes through the gut of the worms, it becomes vermicompost. So vermicompost is really only a fancy way to say worm poop. During the process of vermicomposting, we as waste managers need to ensure that the worms are happy. They need to have a favorable environment so that they can feed and reproduce. And we should look at those parameters. Then we will look at suitable technologies with some examples. Finally, we'll conclude with looking at the products of this waste treatment process, the vermicompost and the worms. So first, let us start off with the suitable worms. First of all, it's important to remember that the common earthworm is actually not the ideal worm for vermicomposting. Why not? Well, this is the type of worm that digs deep burrows into the soil and does not feed as quickly and has a very low reproductive rate. The ones that we are looking for are the surface dwellers. We call these the epigeic group. These are worms which live within the organic material on the surface, and you will find them in your compost heap or in your manure pile. Eisenia foetida and Lumbricus rubellus, the first two on the list here, are the most popular used in vermicomposting. They have a high reproduction rate and they're very flexible regarding environmental conditions, so are actually quite ideal. Here's a picture of Eisenia foetida. It is one of these surface dwellers. It can process large amounts of organic matter, up to its body weight each day. It has a high reproduction rate. Populations can be expected to double every 1 to 3 months. First, let's look at the adult worm. It can be recognized by the presence of a bulge on its front end. Eisenia foetida is a hermaphrodite, which means that it is both female and male. However, 2 individual worms are still needed for reproduction. When they mate, they lay side by side and exchange sperm. Then the worms deposit cocoons. These are roundish and a few millimeters in diameter. An average of 3 worms develop in each cocoon, and these hatch after about 3 weeks. The baby worms then feed and grow to mature worms over a period of 8 to 10 weeks. So what waste can we feed to the worms? Suitable waste are fruit and vegetable waste, plant waste, even bread, rice, and various staple foods. What does not work so well is meat or fish waste, fats, grease, oil, butter, dairy products, or salty or vinegary waste. So now let us look at the ideal environmental conditions for the worms to work as waste managers. Temperature is ideal in the 20s. Below 15 will slow down their activity. Above 32, the worms will want to leave, and at 35 degrees Celsius, they start to die. For hot climate, this means keeping them shaded and moist. Moisture is important. It should always be between 70 and 85, or slightly higher. pH should be neutral or slightly above neutral. pH below 7, so acidic, is harmful to the worms and will also increase the risk of red mites, which are predators of the worms. Worms need air to breathe, so the system should be aerated. And worms do not like light, so we should keep them shaded, and we can actually use the light if we want to move them away from somewhere, for instance, to harvest the vermicompost. Let's look at some other operating conditions. We should provide the worms with bulky carbon-rich bedding. Typically, this is shredded paper or cardboard. Stocking densities are recommended between 2.5 and 10 kilograms per square meter. Below 2.5, the worms will not reproduce as fast because they don't find each other. And above 5 to 10, there will be competition for food, so they'll be stressed out by that. It is nice to feed a particle size of smaller than 5 centimeters because they can process it easier. And often the waste is even semi-composted, so slightly degraded, so it can be fed easier to the worms. Feeding rates, we can estimate about 50% of the worm mass per day as feeding material. So 50% of the body mass of a worm can actually be processed by the worm per day. However, we should not feed this in layers of more than 10 centimeters thickness. Over 10 centimeters, the waste tends to heat up through the microbiological process and therefore is not very suitable for the worms. Now let's look at different technologies. We'll look at worm bins and beds. This can be operated at household level, medium-scale neighborhood level, or even large-scale facilities. Sometimes, but not so often, we also see worm windrows. Here are some examples of household-scale worm bins. Different trays where you can feed the worms with your food scraps. Although such bins are commercially available, you can also make them yourself with normal plastic bins, as is shown in these pictures. Here is an example from Indonesia. It's an example of vermiculture in these plastic bins. Weekly, about 10%, so a corner of each bin, is harvested and the worms are removed. These worms are then sold as shrimp feed or processed to medicinal capsules for human consumption. This is also in Indonesia, and you see it's quite easy to just use one corner in the neighborhood and to stack this with different boxes where vermicomposting is done. Here an example from rural India, where the vermi bins are made with cement rings. And here an example from the Philippines, and here you see how the bins are covered with these bamboo mats to keep them shaded and protected. This is another example from the southern India in nearby Chennai. You see this hut with a thatched roof. Inside are these cement bins with vermicomposting. And what you can also see is this grid, this mesh that covers the worm bins to keep predators out. Finally, also a larger example from the US with these automized vermi bins. This has an automatic feeding and it also has an automatic harvesting system on the bottom through a breaker. So now let's look at the products from vermicomposting. As the feed passes through the earthworm gut, the material is mineralized and plant nutrients are made available. The grinding effect of the gut leads to the formation of small granules. That is quite typical when you take vermicomposting into your hands. You see those granules. Nitrogen content of vermicompost is typically higher than compost. It's around 1 to 2%. And the nutrients are easily available to plants. Furthermore, the enzymes and microorganisms from the gut are also very beneficial for soil and plants, even suppressing diseases. Leachate from the worm bins can also be used as a liquid fertilizer. This is typically used in small-scale systems, and they call this worm tea. Earthworms are rich in protein, up to 65%, with all essential amino acids. They are considered a good probiotic feed for fish or for poultry. In the last 10 years, earthworms have also been studied with regard to their medicinal properties. What researchers agree on is their anti-blood clotting effect. So they were found to be effective in treating thrombotic diseases. Worms are also finding new uses as a source of collagen for pharmaceutical industries. Now you got excited about vermicomposting, and this module is just about over. Here are some references if you want to read more and have more details about vermicomposting. So let's summarize what we've talked about. We've talked about the worms, the ones that are suitable and not suitable, their life cycle. We've talked about environmental conditions which are suitable for vermicomposting. That need to be aerated, it needs to be moist, it needs to be shaded. We looked at daily feed, which can be up to 50% of worm weight per day. We also looked at examples of small and large scale facilities in different parts of the world. And we looked at the properties of the products, the nutritive value of vermicompost in agriculture, and the worms as animal feed. Thank you very much for listening.